I'm Nathan, and welcome to our Bookify website. If you're a small business and you need a website to advertise your list of services, accept bookings, take payments for that booking, and keep track of all your upcoming appointments online, then Bookify can manage this for you. So Bookify is a free online booking application that can be managed by the company itself. For our demo purposes, we have set up a single business called Manchester Codes Dog Grooming, where you customers can make appointments for their dog and pay for that service. Once the payment is successful, Manchester Codes Dog Grooming business will then be able to see this appointment through their own calendar.
Hello, my name is Stuart Green. I'm going to be talking through the software that we use to collaborate and manage our project, as well as some of the back-end tools and technologies that we used on the Bookify system, and just kind of walk over the code a little bit and just look through some of its core functionality.
Hi everyone, my name's Dan. So when you first come to the website, you're taken to the login page. From here, you've got a couple of options. So if you've forgotten your password, you can request a new link here. What this will do is it will just call the back end, check that this email address exists, and then it will send you out a password reset link. If you've not signed up before, you've not got an account, you can come to this page. It asks for a username, and your first name, last name, email address, which type of user you're going to be, so either a customer or a business, depending on how you want to use the site. So I'll go in as a customer, and then it'll ask you to set a password. And this will make a post to the back end, create this user for you, and then that's ready. You can go and log in. So okay, once you're logged in, you're taken to a dashboard page. For now, we've just added in placeholders to show where information can go, so they could have their appointments that they've got coming up once those have been booked. Just some adverts about what sort of services are available near them, and then a rewards section for any discounts or vouchers that nearby businesses might be sending to them. At the top, we've got a nav bar with links to various services or web pages that they might want to use within the app, and then there's a function where they can log out afterwards. So we're going to talk a bit about our code. This is the top level, so this is app.js, and inside here we've imported some of the packages like React and React Router DOM that we're going to be using. We've imported all the components for the nav bars, for the entry pages and the dashboards, and then we've got some user-specific pages and some admin-specific pages, depending on whether they're a customer or a company. Inside the function of app, we've got some state that we've declared initially just as empty, and then we've got a lot of this state inside a value which we're passing down as context throughout the app. That saves us having to prop drill through all the different components. We're using React Router for navigation, and a lot of these routes we've set as private, so if the user isn't logged in, it won't allow them to access these routes, just to keep it more secure. And then inside this container, which is a Bootstrap container, we've contained all the web pages that have got to be in a certain format in a form, just to try and keep some continuity between the pages. And then lastly, the three open routes, which is for login. So now we're inside our login component. Again, we've imported some of the packages we're going to be using at the top of the file here. One of them in particular was JWT Decode. The authentication we used for the website was JSON Web Tokens, and when a call's made, we're going to be using this later on to verify that the user's logged in and also to get their role ID. We've got some of the state that we've pulled in through context, and then some of the state that we're just specifically using for login. And then we've got a function for when they submit the form. This is going to make a post request to the back end. It's going to send off the username and password, and then if that's successful, it's going to send us back a token, which we, inside this use effect, store it, we decode it, and then we destructure it to get out the user's role ID and their user ID, which we're going to be using later on. We make another call back to the back end, which gets the user's role name using the role ID we've received, and then that role name is what determines whether the navbar is a user navbar or an admin navbar or a super user navbar. And then inside the actual body of the return, we've just got some more bootstrap styled forms. So sign-up's fairly similar to the login component in that we declare some initial state which matches the fields they need to fill out. At the top of the component, we are declaring some of the state that we're going to be using. We've got a handle on click function which updates our state every time the fields are changed within the sign-up form. And then when they submit the form, some logic's just performed to check that the passwords both match and the passwords are over 8 characters long. That satisfies the restrictions on the database. Also, it checks to make sure that all the fields have been filled out correctly. As long as that's all okay, it will send a post request to the backend and it will send these fields in the body. If it's successful, the sign-up completes and the user's details are stored. If not, it just returns an error back to us. And then we've got some bootstrap styling again.
So I just want to talk briefly about the tools and technologies that we used on the back end. So starting with TypeScript, we opted to use TypeScript for a couple of reasons really, but I'd say the main reason was probably down to, one, just wanting to kind of learn how it works, use something new, and two, down to probably how easy it is to gobble up those pesky little bugs, or at least most of them. Because we're passing everything around in interfaces and things like that, it just makes it really easy to basically catch bugs in real time when we're making changes, which we did do quite a lot of refactoring, so that definitely came in clutch. We used Express for the API. Using Express basically just allowed us to kind of focus on what actually mattered in the application without having to worry about too much sort of low-level stuff. We used JWTs for authentication and authorization. The main reason for using JWTs, I'd probably say, was because they are stateless, which is what we want in a REST API, as well as it being fairly easy to implement. We used bcrypt to hash our passwords because obviously no one wants a plain text password stored in the database, and we use Postgres as our relational database. I think I touched on it briefly earlier. Yeah, our application has a lot of relational data in it, so it was kind of paramount for us to choose a good relational database. Postgres has a pretty good reputation, I would say, from our research, as well as the PSQL tool being amazing. I would say, I really liked it. So we use database migrations to basically just make sure that when we were developing, just kind of ensure that everyone had the same database schema and we were all kind of up to the same stage. But another added benefit of that, I would say, of using the database migrations would be that we had a pretty well documented list of what changes we've made to the database, I would say. So that was really helpful as well. Another thing we used was the Stripe checkout API and webhooks in Stripe. So we used the Stripe checkout API just to kind of allow users to purchase things in Bookify, and we utilized the webhooks in Stripe to update payment statuses at a later date. So basically it goes in as unpaid, and when a user's paid, we switch it to paid. We used TS Jest and Supertest for testing, as well as Insomnia. We did a lot of testing in Insomnia, mainly due to time constraints. We would have loved to have done more tests, I would say, in Jest and really bump that up, but we did at least get some done. And yeah, we used Docker for basically our local instance of Postgres. We spun up a Docker instance for that and sort of worked through that until we pushed it live. Which brings us on to the next point, which was Heroku. And yeah, we pushed the backend up to Heroku, and that's now where it lives.
So for the front end, we used React to build the app itself, and we used CSS to style it. Some of the packages that we used were Axios to make calls to the backend and to the database. We used Bootstrap to style the forms that we were sending. We used JWT decode to decode the web token that came back when we first logged in. We used Material UI, Date Picker, Moment and Scheduler to design the calendar and the booking form. And then we used React Router DOM to navigate around the pages.
So I'm just going to go through the customer side. So the view we got now is the dashboard for the customer. The customer can access the Services tab and view the list of services that Manchester Coach Grooming offers. Manchester Coach Grooming can add and remove services from this list. But as a customer, they can review it, see what's on offer, got the price and the time, and then they can go to the bookings tab. They can make a choice of what service they want. So I'll go for the full service, and then just select the date and time of when you want to make that appointment, which we'll go for Monday the 23rd. Let's go for a morning appointment of 11 a.m. So then when they press to make this booking, it will take them to Stripe to make that payment for the service. So this is Stripe now. So as you see, it's a full service. It's £30. So the customer just needs to get details to make payment, which aren't some dummy payments. And then once the payment's been made and successful, that booking will then fire over to Manchester Code Stock Grooming, and that should show then on their calendar for the booking. So it's successful. We should see a green tick. Yep. Bit of code on the front end for the user bookings page for the customer. We used a couple of React hooks, used context being one, which allowed props to be accessed through our component rather than need to pass them down manually. We used useState, and we used a use effect hook, and inside the use effect hook we had an Axios GET request, which we were requesting back from the backend API all our available services, which we then used to open up in a list, drop-down list, for the user to, or the customer to select one of the services that they'd like. We also then had to use an Axios post request to our Stripe create checkout session using the date and time, user ID and the service ID, pushing those props. And then we use a dot there with a window dot open, which allowed the Stripe create checkout session to be open in a different window. And then we did use a third-party package for the date and time called Date Picker, which saved us a lot of time, and it was in a format that suited what we needed. So we used that. Very useful.
So I'm just going to jump straight into VS Code here because I want to just walk through some of our models, some of our model methods, and just in general design decisions when it came to creating models. So over in VS Code. The first thing I want to talk about is actually down here. So we opted to represent our database tables as classes, whereby each instance of the class will become a new record in the database table. And yet the second thing I want to talk about is just here. So we actually defined a TypeScript interface as well for our different entities in our database. So this essentially just details the sort of structure that a record has to conform to in order to be considered a type user in this case. So let's just scroll down a little bit and go to model methods. So we've got an index, which is going to return a collection of users. We've got the show method, which is going to return a single resource of a user. We've got the create method, which is going to create a new user and store it in the database. Also, just to note, we never store passwords in plain text. We use a library called bcrypt to actually hash our passwords. And we actually take it one step further and actually pepper our passwords as well. So the user's password, and we sort of append a pepper onto the end of it, which is just a random string. We sort of concatenate that onto the end of it. We then hash that a number of times, which in this case I believe is 10, but it's whatever we'd set in this variable. And yeah, that just essentially makes it so if the password ever gets stolen from a different service, if it ever gets leaked from a different service, it's likely not to work on our service unless we unfortunately had the exact same pepper as them, which would be very, very unfortunate. But that's just essentially what we're doing here. Cool, so I'll just come down a little bit further. So we've got an update, which is going to update a specific resource. Also, just a note here, we actually don't let the user reselect their role ID because we don't want someone to be able to just create themselves as a customer and then set themselves as a super admin or something like that. So we just take it from what it already is. Again, hashing the password, salt and pepper in it. And then destroy, which is just going to delete a specific user. And essentially we do the same thing for all our different models. They're all built the same way. They all follow the same structure. So we've got the interface and then the class, and we've got the model methods. So these are just the CRUD methods or the CRUD functionalities we've got at the moment. I will walk through some of the more detailed functionalities in a short while. I'm going to jump straight back into VS Code now and just take a look at some of the more complex model methods that we've got. In the calendar store, we've actually got one that lists out the calendar bookings. So each calendar has its own bookings associated with it. So essentially we take in a calendar ID and we get the bookings that are related to that calendar. One thing to note is that the React schedule that we use on the front end to display it in a calendar format required it as a start date, end date, and title. Title wasn't a problem because we store it as title as well in the database, so we just left that as is. Booking, we actually alias the start date, so booking is our essentially start time and date combined. And we don't store an end date because each service has its own different duration, so not all services are the same duration. So yeah, we took the booking start date time and we actually just appended the duration onto that in minutes. So giving us the end date, and we just alias that as end date. Let's just take a look at maybe the user Authenticate method. So this is how a user signs in. They give us the username and password in the request body, and we're just going to check that essentially. So we're going to use the bcrypt again to essentially just compare the password. So we're going to take that password, we're going to append that random, or not random, that pepper onto the end of that string, and just compare it against the password digest that we've got in the database stored. So that compare sync is just going to take the password, put the pepper that we added on when we created the user, hash that password however many times we've set, and then yeah, compare it against the password that's stored in the database. I'm going to jump back into VS Code again, and this time we'll take a look at the Stripe router and Stripe controllers. So back in VS Code, I'm going to jump over to the Stripe router, and yeah, we can see we've got two different routes. We've got create checkout session and we've got webhook. Create checkout session is actually going to create a checkout session on Stripe and eventually return a URL to the user where they can check out. And the webhook is essentially going to be how Stripe contacts us after the user's completed their checkout session and actually paid for the product or service, sorry. And once they've paid for it, we're going to get a notification and we're going to update our database accordingly. So the status of the order gets marked as complete. So let's take a look at Stripe checkout session first. And we've actually separated the checkout session into a bunch of different helper functions now because it is quite big. So we essentially, first of all, we create the booking. Now we create the booking by essentially getting all the information we need. So we get the user ID, the service ID, so we can know what user it is that's purchasing. We can get the service that they're actually purchasing, and then we create a booking that's got essentially those details. Let's come back out of here. We also store those details on res.locals because we're going to need them a little bit later, as you can see here. And then we actually create the checkout session. So this is where we're going to essentially get that service title, which we've got from the service ID. We get the service description again and the price from the service ID. Currently, everything can only be purchased in quantities of one, but that would be a very easy change if down the future we wanted to just add that to the request body, where they can obviously choose an amount of quantity. And then yeah, we just essentially create that checkout session here, and we also store the user ID, service ID, and booking ID in Stripe as well, just in case we ever need them there. But these are all obviously in our database as well. Come back out, and then yeah, we actually then create an unpaid payment. So essentially this is going to create the payment using the new Stripe checkout session. So from there we get, when we actually create this checkout session, we get the payment intent, which is going to be a reference to that payment. We get the amount and the status, and then we create a payment with that. And then once we've created that payment, we'll essentially update that booking that we created at the top to have that new payment ID in there. And this just means that if, say for any reason there's an issue with Stripe, we still want to capture that booking, just in case we want to maybe contact that user and say, we noticed you was trying to make a booking, but something went wrong or something like that. This just allows us to do that, whereas obviously we create it after that create payment, after we make that initial payment, we'll never get access to that, because if there's an issue with Stripe, we'll never know about it. So that's just what we do here, and yeah, we then eventually return the checkout URL. So we've now seen that we can create unpaid bookings, but we need a way of actually marking those bookings as complete once the user's actually made a payment. And that's where the Stripe webhook comes in. So we've created a webhook that looks for specific events coming from Stripe. So Stripe can notify us and say, hey, this user's checked out successfully, they've paid, do what you want, essentially. So what we're going to do is actually update the payment status on our end in our database and say it's complete. So let's take a look at that. So in the Stripe router, we've got another controller, Stripe checkout update. You can click on that. And then, yeah, here's what we're doing. We're just essentially getting the payload from the request body, which comes from Stripe. We're also checking that it actually does come from Stripe and confirming that. If it doesn't, then we're just going to throw an error. And then, yeah, what we're going to do is going to wait for an event to happen. So we're waiting for a checkout session complete. In the future, we might also want to look for checkout fails or maybe some other things. But for the time being, checkout session complete is enough. And what we're going to do is just basically update the payment status once a user's checked out and Stripe's gone, yeah, cool, they've checked out successfully, they've paid, do what you want now. So the last thing I'm going to show you now is just briefly walking through the checkout, just so we can get to see the webhook actually updating. So Stripe actually notifies us and updates the payment status. Well, so Stripe actually updates us and then we update the payment status. So yeah, let me jump into VS Code. I'm actually going to just open up my Postgres on our Heroku server. Cool. And let's just first check the bookings so we can see how many we've got. Okay, so we've got 26 bookings at the moment. So let's actually create a new booking by coming over here and actually creating a checkout session. So I'm going to post a new checkout session. I get back this URL from Stripe, which is going to be the checkout session itself. If I click on that, it's going to open up this checkout page, and notice that it pre-populates a bunch of the details for us, like the actual service title, the price, the description, as well as the user details. So let's just put in some random information for now. Yeah, that's fine. That seems fine. And just put in the default details. Cool. So right now we should actually be able to see that we've created a new booking. So what we're going to do, we had 26 before, and now we've got 27. This is our payment ID, so let's just check that out. Select all from payments. We can see that 19 is actually unpaid at the moment, but let's just pay for this order. Let's save that. It's actually not going to, it's going to redirect me, but this is going to fail for now because I don't have the front-end server running, but it's still going to have updated our database because we paid successfully. So what we'll do is we'll now select all from payments, and now we can see it's been marked as paid, number 19. So cool. And if we also go to the Stripe dashboard and just refresh this, we can see now that we've got a successful payment of super user, and we see all the details in here. And likewise, I did say we'd stored some details in here, which are here as metadata, and we've got the user ID, the service ID, and the booking ID, which have obviously all come from the database as well, but just so we can kind of easily tie the two systems together as well. So I just wanted to finish out by just saying a huge thank you to both Dan and to Nate. I really do appreciate the hard work and effort that you've both put into the project. I know it wasn't always easy. We did have some struggles, but we overcame them, and that's amazing, to be honest. I'm really, really proud of the project that we've created, and yeah, like I say, I've had a lot of fun working with both of you, and I really do hope we could do it again in the future sometime. As well as that, I'd just like to say a thank you to Manchester Codes and all the tutors at Manchester Codes who've helped me along the way. And I'd just like to close out by saying best of luck to all my fellow cohorts as well. Yeah, good luck for the future.
Big thank you to Manchester Codes, to all the tutors that have helped over the last 6 months. And I wish all the cohort in October 2021 all the best in the future.
So thanks very much for watching. I hope you liked the presentation. If you've got any suggestions or questions, then just drop them in the comment box below.